So how's everybody doing out there today? Well, welcome to day 21 of Corona Online School. So before we actually got started into more of the hypothesis testing, which we're going to work on today, so we're going to look at when the sigma is unknown and the proportion hypothesis testing. I wanted to make sure that everybody kind of understood when to use like which normal CDF and stuff like that. So I realized I might not have been as clear as I should have been in the last example, and some people were a little confused and stuff like that. So I wanted to clear that up kind of first before I went into the actual lesson itself. So the thing to remember is we really only have three possible like setups for hypothesis testing. So remember we've got our H naught is mu less than or equal to some number. So I'm just going to use 0 for all these for right now, just to make life easy. And that means our H1 would be mu is greater than 0. And then we have our H naught is mu greater than or equal to 0. And then our H1 would be mu strictly less than 0. And then the last one is our H naught is mu equals 0. And our H1 would be mu not equal to 0. So when we have these different situations, then what we're going to get is like a kind of a different graph for our normal curve for each one of these. So our normal curve for the first one that we're interested in. So since our mu is greater than the thing that we're trying to actually discover, then what's going to happen is this is going to be, so our 0, remember, would be in the middle. And so I didn't draw this very well. It should be further over. But the alpha level that we're trying to get into, like our critical region, is going to be on the upper right-hand side. So since this is a greater than, it matches the greater than up here. And so the alpha that we're trying to land, this is where we want to be. So this is going to be where we want to land to be able to reject H naught. So that's going to be in that little alpha. So if alpha were, 5% or something like that, then we've only got this little 5% area to reject H naught. Then everything down this way, the other 95%, is going to be in the fail to reject. Oops, I didn't draw that very well, but and of course I just erased the whole normal curve. So, so this is going to be our fail to reject H naught. So when we're setting this guy up, then this is going to be one of the normal CDF where we would end up with whatever our sample mean is, comma 100,000, and then comma, whatever, comma 0, comma 1, whatever it happens to be, whatever our, I guess I should write in the mu, don't use 0 and 1. So mu and then sigma over square root of n. So let me be precise about it and write it down that way. So that's what our normal curve is going to look like. If we land in that little purple shaded region, then basically we know we're good to go. We're going to get a p-value that's less than our alpha if we land inside of that purple region. All right, so if we've got the opposite and the mu that we're interested in is less than 0, then our normal curve is actually going to be this way. So in this case, let's again, just for argument's sake, let's assume this is alpha. So this is actually the low alpha. So if you were doing inverse norm on this to figure out what this value would be, then this would be inverse norm 0.05 because it's the 5% on the lower half, where the inverse norm on the upper half would have been 0.95. So if we were doing the inverse norm on this, we would have been looking at the 0.95 version because of where it was at. All right, so again, in this case, so the part that we want to land in is our lower 5% in this case. So again, we'd have our mean or whatever, it would be in the middle. So this is going to be our reject H naught region. And then everything this way is going to be our fail to reject H naught region. And so again, when we're setting this one up, since we want to go to the left, so we would do normal CDF negative 100,000, our sample mean, comma our mu, comma our sigma divided by square root of n in this case. And so both of these, notice because only one side is shaded in, these are both considered our one-tailed tests in this case. So these are our one-tailed test. So if mu is greater than or mu is less than, it's always going to be a one-tailed test. All right, so let's move on to the only two-tailed test we have in this case. So this is going to be our two-tailed test. So two-tailed test is when our mu is equal or not equal. And so again, we've got our nice normal curve. But in this case, since it's a not equal, then that means we could actually be okay if we land far to the left or if we land far to the right. And so in this case, where we have to be careful is if our alpha is 0.05, so it's not 0.05 over here and 0.05 over here. This is just like our confidence interval. This is where we have to divide that value by 2. So in this case, our upper percent is going to be 2.5%, and our lower percent is going to be 2.5% as well. So again, we've got where we could be good in either of these regions. So in this case, if I'm down here, whoops, I wrote the wrong thing. So if I happen to be way over here on the left, good. I can reject H naught if I'm out in this area. Or if I have to be way over here on the right, I can reject H naught on the right. So the only bad spot for me is this in-between area, and that's where we would fail to reject H naught for these guys. So now the way we're going to do these to calculate our normal CDF, and so it doesn't matter which one you do it, because remember this normal curve is symmetric, but we just have to decide to do either the upper or the lower. So it's up to you, whichever way you prefer. So I'm just going to do the upper part. I'm going to calculate this part here. So that means I'm going to do normal CDF, my sample mean, comma 100,000, comma my mu, comma my sigma over square root of n. But that's just going to give me the probability of landing in that one section. So the problem is there's another section down here. So if you wanted, you could do normal CDF, negative 100,000, comma sample mean, comma mu, comma sigma, comma divided by square root of n, and just add them together. Or you could just multiply this answer by 2. So that way, again, because it's symmetric, both of these guys are even. They're both going to give you the exact same probability. So however you want to calculate it, it's kind of up to you. So, and again, I could have calculated the bottom half and I would have gotten the same thing. So remember, this 2 times only applies on the two-tailed test. So I multiply my answer by 2 because it's a two-tailed test. So keep that in mind. I didn't have to multiply anything up here because it was all one-tailed test and stuff. So let this sink in. I'm going to stop this video, start a brand new one for the lesson. I hope this helps. I hope it clears some stuff up. If you already knew how to do this, I'm sorry I bored you with talking about it, but I wasn't sure if everybody understood, and I like to look at the visuals and the pictures and stuff like that. So, give me feedback on it. Let me know if this actually helped or hurt or anything like that. Otherwise, I'm going to start the other video in a second here. So good luck. Let me know if you have any questions about this or if this was clear or confusing or not.